Going to show you how to calculate the pressure and force exerted by the gas molecules on the walls of the container. Consider a gas enclosed in a cube of side L and area is equals to L square. A molecule with velocity Vx, Vy and Vz hits the planar wall parallel to the YZ plane. It rebounds with the same velocity but its x component gets reversed, so y and z component remains same. The collision with the wall is perfectly elastic collision. Now let us calculate the change in momentum during this collision. From this, which is final momentum minus initial momentum. From this diagram we can say that the final momentum is minus mvx minus of initial momentum mvx, which gives minus 2 mvx. During calculation we take the mod of this value, which gives 2 mvx. To calculate the force and pressure on the wall, we need to calculate the momentum imparted to the wall per unit time. In a small time interval delta t, a molecule with x component of velocity will hit the wall if it is within the distance vx delta t. So distance can be written as vx delta t, which we get from the formula distance is equals to speed into time. The volume also can be calculated. All molecules with volume avx delta t will hit the wall in time interval delta t. We get this equation from the formula volume is equals to area into distance. The total momentum exerted by the molecule can be calculated by Q, which is change in momentum into half NAVX delta T. We get this half NAVX delta T from the equation of this volume. Volume is equals to AVX delta T. Since half of the molecules are moving towards the wall and half of the molecules are moving away from the wall, we always take positive values for calculation purpose. So we write that half AVX delta T, as half molecules are moving towards the wall. As n molecules are moving towards the wall, we write volume is equals to half NAVX delta T, which I have put in this equation. So the total momentum can be written as Q is equals to 2 mvx into half NAVX delta T. 2 get cancelled. So the resultant equation is half mvx square a n delta T. From this equation we can calculate the total pressure exerted by the wall, exerted on the wall, which is force per unit area, and we know that force is change in momentum per unit time. So we can write this as force delta Q by delta T into A. Delta Q is mvx square A n delta T by A delta T. A delta T and A delta T will get cancelled to give us the equation mvx square n. We know that in a gas the molecules move with nearly same velocities. So we can write that Vx square is equals to Vy square is equal to Vz square. The average velocities of these molecules are nearly same, which equals to V total Vx square is equals to Vy square is equals to Vz square. Now we can write that the total velocity V total is equals to sum of Vx square plus Vy square Vz square, which are the individual velocities. From here we can say that Vy square and Vz square is equals to Vx square, that is equal to 3Vx square V total square, and Vx square is equals to 1 by 3 of V total square. Now let us put this value in this equation. So we can write pressure as m Vx square n. Vx square is 1 by 3 V total square, therefore 1 by 3 m n V total square. This V total square is known as the mean square velocity, which is the square of the average velocities of these molecules. So the pressure exerted by the gas molecules on the walls of the container is 1 by 3 mn V square, V or V total square, and the force is delta Q by delta T, or mvx square A n delta T by delta T, that is equals to mvx square n into A. Thank you for watching my video. Please like my video.